Manufacturability Research and Education Center presents lecture number 10. The topic of discussion is Design for Manufacturability. This is part of lecture series on Operations Management. The teacher today is Dr. Subhash Kakkar. He is PhD from FMS Delhi University, Delhi, India. He is MBA from FMS Delhi University. He is BE Mechanical from Delhi College of Engineering, Delhi University. He is Six Sigma Master Black Belt and SAP R3PP consultant. He has over 40 years experience of corporate sector and academics. Presently, he is working as director in Adhere Research and Education Center, Delhi, India. Today's topic for discussion is Design for Manufacturability. We'll gather information regarding Design for Manufacturability. In short, we call it DFM. Sketches, drawings, product specifications and design alternatives. A detailed understanding of production and assembly processes. Estimates of manufacturing costs, production volumes. DFM method. We go to first proposed design. We estimate the manufacturing costs. We reduce the cost of components. We reduce the cost of assembly. We reduce the cost of supporting production. Consider the impact of DFM decisions on other factors. Then we recompute the manufacturing cost. If it is good enough, we go to acceptable design. If it is no, we go back to estimate the manufacturing costs. Now, we'll DFM method, estimate the manufacturing costs, reduce the cost of components, reduce the cost of assembly, reduce the cost of supporting production, consider the impact of DFM decisions and other factors. Now we estimate the manufacturing costs. Total manufacturing system, what are the inputs? Starting from the top, equipment, information and tooling. On the left hand side we have written raw materials, labor, purchased components. And at the bottom we have written energy, supplies, services. And two things are generated. One is finished goods, other is waste. Manufacturing cost defined sum of all the expenditures for the inputs of the system, that is purchased components, energy, raw materials, etc. and for disposal of the wastes produced by the system. Elements of the manufacturing cost of a product are components, assembly, overheads. Under the component sets we have written standard and custom made. Under assembly we require labor and we require equipment and tooling for assembly. Overheads, support and indirect allocation. Under components, custom made components are raw material, processing and tooling. Manufacturing cost of a product, component cost, parts of the product, parts purchased from supplier, custom parts made in the manufacturer's own plant or by suppliers according to the manufacturer's design specifications. Assembly cost, labor, equipment and tooling. Overhead cost, all other costs. Support cost, material handling, quality assurance, purchasing, shipping, receiving, facilities, etc. Indirect allocations, which are not directly linked to a particular product but must be paid for to be in business. Fixed costs versus variable costs. Fixed costs incurred in a predetermined amount regardless of number of units produced. That is, setting up the factory work area or cost of an injection mold. Variable cost incurred in direct proportion to the number of units produced, cost of raw materials, etc. And now we have to reduce the cost of components. Understand the process constraints and cost drivers. Redesign components to eliminate processing steps. Choose the appropriate economic scale for the part process. Standardize components and processes. Adhere to black box component procurement. What is black box? Only purpose of the component is given to the supplier. When we order some material, the supplier should not be given all the details of the component, but only the purpose of the component should be told, and supplier should be able to supply the material. Understand the process, constraints and cost drivers. Redesign costly parts with same performance while avoiding high manufacturing costs. Work closely with design engineers, raise awareness of difficult operations and high costs. Redesign components to eliminate processing steps. Reduce the number of steps of the production process. Will usually result in reduced costs. Eliminate unnecessary steps. Use substitution steps where applicable. Analysis tool, process flow chart and value stream mapping. Here we can do the process mapping to see which are redundant processes and those should be removed from the process sheet. Choose the appropriate economic scale for the part process. Economies of scale: as production volume increases, manufacturing costs usually decrease. Fixed cost divided among more units, variable costs are lower since the firm can use more efficient processes and equipment. Standardize components and processes. Economies of scale: the unit cost of a component decreases as the production volume increases. Standard components common to more than one product. Analysis tools, group technology and mass customization. Adhere to black box component procurement. Black box only give a description of what the component has to do, not how to achieve it. Successful black box design requires clear definitions of the functions, interfaces and interactions of each